Hi, welcome to Azure Conf. I hope you've been enjoying today's sessions, and if you're tuning in with us after the fact and watching the recordings, please go back and watch all the sessions for the conference. There's a lot of great presenters and a lot of good material. I'm going to be talking about Azure Automation, and my name is Mike Wood. I am a technical evangelist for Cerebrata, which is a group within Redgate Software that makes development tools for Azure. But today I'm going to focus on Azure Automation. Before I get started, I do want to talk about justazure.com, which is a website only about Azure, as you can tell from the name. We have some great content out there from folks that you've actually even seen today during Azure Conf. We focus on articles telling people about what people use Azure for. We call that the Azure in the Wild series. And then we also have a whole series dedicated to individual features of Azure. So it's a fairly new site. We'd love for you to come out, check it out, and tell us what you think. So what's on the agenda for today? Well, we're going to cover why is automation important? Why should I even be paying attention to this? What makes automation different in the cloud? And then we're going to talk about what is Azure Automation. This is the service from Azure. And then we're going to talk about some scenarios in which you might want to use Azure Automation. So why automation? If you've ever been working with a bunch of machines in your own data center, you may have found very quickly that humans just don't scale, right? This is a picture of a gentleman named Andre, and Andre is preparing to purchase his ticket for CodeMash. Now, CodeMash is a great conference up in Sandusky, Ohio, and it usually sells out in minutes, if not seconds. And so Andre has set up a variety of machines that he can hopefully obtain one of his tickets. Unfortunately, as you can already tell, Andre can only really pay attention to one of these at a time. And if he tried to take care of more of it at a time, it would just fall behind. It wouldn't work quite well. That's because humans don't scale. We have the same scenario when we look at cloud machines, right? If we have a series of machines set aside to do some tasks, and we have to monitor those machines, we have to care for those machines, we have to determine, are they doing what they should be doing? Is there a problem with our application? If there is a problem with our application, how fast can we respond to that? And if we're talking about one machine, 5 machines, that may be okay. But if we're talking about dozens of machines or hundreds or even thousands of machines, that's just not going to scale. So automation helps us overcome that by recording a lot of the little things that we need to do, putting those into scripts, and then making them available to run at a moment's notice. But speaking of when we have to do it manually, humans are incredibly inconsistent. So not only do we not scale very well, we tend to be inconsistent. We will do things differently each time. No matter how hard we try to do it exactly the same as we did last time, there might be some little nuance that we do differently. And this becomes exponentially worse the more people that need to do that task. So if you have a way that you roll out your deployment, and you've got the scenario where somebody is deploying it in one manner and there's a list that they go down, they may choose to perform one of the operations slightly different than someone else. And that can cause problems. And that's why automation helps us get around that. I come from a background that's pretty deep in the Boy Scouts. I've grown up as a Boy Scout. I've spent a lot of time helping the Boy Scouts. And I really love the motto, be prepared. Azure Automation, or just automation in general, helps you be prepared for when things don't go quite the way you expected them to. Or it allows you to prepare for consistent operations that you're going to do time and time again. It's great to have the idea of automation to help you recover from small blips or problems that may occur in your data center and your solutions. The idea of if we have to roll over to another region or deploy out to another data center, we can do that simply by running this script and not by pulling out some 50-page Word document and going through it checkmark by checkmark. That's especially important when if you're actually manually having to do that, you're probably under a tremendous amount of pressure to get it up and running. Having that already automated and ready to go is a great time saver. And finally, when I first started as a consultant, I had a gentleman who was very experienced tell me, the GUI makes you weak. Now, he really wasn't making fun of GUI tools in general, because they are very, very helpful. They allow us to get things done very quickly, and if they're made well, they're very intuitive to use. However, they suffer from the same problem that humans suffer from, right? They don't scale very well. So by having the ability to automate those tools makes it a lot easier to provide solutions that will get us up and running, do deployments, keep us moving, all of that without having to go click, click, click. So we're going to talk about Azure Automation and what it gives you out of the box. And now Azure Automation is a service provided by Azure where we can run scripts up in the cloud to affect things in our own subscriptions as well as just things out on the internet if we need to. So let's talk a little bit about what you do get out of the box. So with Azure Automation, as I said, it is a service. It is backed by PowerShell workflow. So if you're familiar with PowerShell, or you've worked with PowerShell workflow, or in particular, if you have any experience with System Center and Orchestrator, then this will be very familiar to you. In fact, a lot of similarities have been drawn between Orchestrator and System Center, and then this just being that type of service hosted in Azure. So we get our great workflow capabilities from PowerShell, where we can suspend and resume workflows. And we also have that ability to break up our workflow or our process into smaller little bits, piece them all together so that we have a full end-to-end solution with bits and pieces that we can reuse over and over again. And I'll actually show that in one of the demos. And we also have some auto recovery built in. Because we have the concept of these checkpoints and because it's hosted for us, we get the ability to recover if there are problems. And again, I'll talk about that a little bit later. Because it's a service, we have a centralized store of information and metadata. This is the same place that we would store values that we want our scripts to share, things like credentials to accounts or additional modules, or even what schedules we want to share so that we can use them across our scripts. This shared store also is nice because that is shared up in the cloud and it's stored in Azure for us. So we have a lot of high availability of that solution, and we know that that data is stored. And if we lose connection to our on-premises data center, that's okay, right? Because this is running up in Azure, we know it will run for us. Which brings us to the high availability portion. We get cloud execution of our scripts. They actually execute up in the cloud. We have an API for management, which they are working on. As of right now, during the preview for Azure Automation, the best way to interact with it is through the portal, which we will show, and they also have PowerShell commandlets. But eventually there will be an API that they have talked about, and all the data is stored, as I mentioned before, all the data is stored in that centralized store for high availability. And then, of course, it wouldn't be a good scheduling system if we didn't have a way to go back and look at the history of execution to make sure that our jobs are working the way we expect them to, how did they react, and did they complete as we expected. So as we get going, let's start a little bit with some definitions, some things that you should be aware of with Azure Automation. So we have an Azure subscription. We're probably very familiar with that. Within an Azure subscription, you can create an Azure Automation account. Now, this is a separate thing. You can have multiple of them, and they are tied to regions. So in this particular case, during the preview, they're available in US East, and we'll see more and more appear over time, especially as the service goes GA. So each one of these accounts are broken down and pointed to a particular region. You can have multiple accounts for the same region if you'd like. And a couple of things that you might use, or a couple of reasons you might want to split these up into separate accounts is perhaps one has access to credentials that are used for production, or perhaps one is tied to a particular person, and that person is maintaining and using those scripts. Beyond our account, we have assets. Now I'm going to dive deep into the portal and show you a little bit about the assets and how those are used and how you store them. But understand that anything that's in the assets is shared across the entire automation account. And these are things like the schedules, certificates, the actual scripts themselves, and variables. So if I have a variable that I want to be able to set globally across all my scripts, then I can set it here in the assets, and it can be pulled in and used at runtime by the scripts. And then I keep referring to them as scripts, but their actual terminology for Azure Automation is runbooks. And if you're not from a orchestrator system center background, runbook may be a new term for you. But in the end, a runbook is simply a script or a set of scripts that you can execute. And when you execute them, they become an instance known as a job. So a job is simply the instance execution of a runbook. So now that we have definitions figured out, let's talk about schedules. You can schedule schedule a runbook either daily or n times a day, or hourly or n times hourly, or you can schedule it to run just once. And of course, this service is in preview, so they're taking all sorts of feedback on what kind of schedules people really need to see and how complex those schedules need to be. So we've given definitions to things in Azure Automation, and we've talked about a few things. Let's dive in and actually see where you can do some neat stuff with Azure Automation. So I'm going to jump over to the browser here. Now, to get started, if Azure Automation is in preview, you have to sign up for it. So you can go out to the azure.microsoft.com/services/preview and scroll down. It's currently near the bottom, but you just come over here to this Azure Automation and you click Try It. And you'll be able to select which subscription you want to apply that to. And once you get approved, then when you log into the current Azure portal, you'll be able to scroll down the side here on the left, and you'll find the little gears and the lightning bolt, and it'll say Automation. Now, as of right now, Azure Automation is only available in the current Azure portal. It hasn't quite made it into the Azure Preview portal yet, but you can see that will light up at some point in the future. So we have Automation, and I have an automation account. To create an account, you simply come down here and click Create. You type in an account name, and you give it the region. That's all you have to do. It'll give you an account. Setting up the account is very fast, very painless. So I've already created one. So we'll go in. You get this little dashboard, and it will show you basically jobs that have run over the last X number of days. You see some information about how many have run, how many have gone into a suspended state, things like that. Now, I will point out in this dashboard this section right here. So this is telling me the usage that I have done on my Azure Automation account. One of the metrics that is used to determine how much you pay for Azure Automation is how many minutes you get, right? Now, if we take a look at the pricing details, we'll see that there's actually a few things to determine which tier I should get. Now, in the free tier, the price is obviously free, and I get 500 minutes a month to use in Azure Automation. And that's measuring from the time my script starts until it completes. And then I can have up to 20 runbooks, and I can store 5 megabytes of other modules. And we'll talk about importing modules here in a second. Now, when we look at the standard tier, which is currently free during preview, it'll be $20 a month, but it gives me 10,000 minutes of runbook time. I can store 100 runbooks and 25 meg per module. And this is per account. So let's flip back to the portal here. And we can see I can look at the jobs over the last couple of days, and it just gives me a little bits of information. So as we scroll back up to the top, I'm going to jump to the Assets tab, and we're going to talk a little bit about assets. So as you can see, I already have several different types of assets in my account here. The first one is actually a Twilio cert, and this is a certificate, and I'm using this certificate to make sure that I can communicate with the Twilio service. Now, if you're not familiar with Twilio, it is a service that you can use to send SMS, to receive phone calls, or to actually make phone calls out to folks. I'm using it here. We won't show it off in the demos, but there is a Twilio module that was written by someone at Microsoft you can download and put into your Azure Automation scripts and actually send text messages from your automation scripts. It was very quick and easy to set up. But back to the certificate. When I run a runbook, it does not have access to any of the HTTPS certificates, so it doesn't actually trust any root certificates. And so in order for a call to be made to an HTTPS service, I actually have to load up that certificate so it will travel around and be pulled in by the runbook and be able to be used. So I have the Twilio cert. I also have a Twilio connection, which is actually set up, and it allows me to provide my auth token as well as my account SID, which you would get from the Twilio service. Other types of assets can be modules. So we have the Twilio module. This is actually me uploading that module from Microsoft's Script Center. And I actually found that by going out to this Script Center. I'll have a link to this at the end of the session. But this is a really great resource for some scripts that have been put together by folks at Microsoft as well as the community. And you can pull these down and import them straight into your automation account. So I was able to find one on Twilio itself and pull it down, and it came with these 3 PowerShell commandlets that I can use to send SMS or to get phone numbers in from my account, things like that. And as I mentioned earlier, pulling in one of the integration modules actually takes up a small amount of space, and that's one of the metered things. At a free level, I can only have 5 megabytes worth of automation modules, and then at the standard level, I can have more. By default, they provide for you the Azure PowerShell commandlets module already put in place. And whenever you start an account, at least when I started this one, it was 0.8.6. And if you're familiar with the PowerShell commandlets for Azure, you'll see all the ones that you've used in the past available here. If I want to pull in a module, it's really as simple as clicking Import Module down at the bottom and then browsing out to a zip file that contains the modules itself. And it will just pull those right in and make them available. I have also created a schedule, which I'll talk about here in a little bit. But the other thing I wanted to point out here was I have 2 variables. In this particular case, I've created a string variable that I'll use during my demo. And it's going to be used to ignore some services that I have running while it's doing an operation. And I just plug in the variable here, and then when we get to the demo, you'll see that I'm able to pull that out of that centralized store very easily. And the final type of asset that I want to talk about is the credential asset, or the PS credential. So if you're familiar with PowerShell, a PS credential is a PowerShell object that you can use to store a username and password. And then you often use these to pass them along when you talk to other services or to other computers. They have provided a mechanism now that allows us to use Azure Active Directory organizational accounts to connect and manage our resources in Azure. And so as of the PowerShell commandlets 0.8.6, you can actually pass a PS credential along as your token to authenticate you when you work with your assets in Azure. Prior to that, you would actually load up a certificate and pass that certificate or sign all the calls with that certificate. That is now no longer the preferred mechanism for you to use. They'd rather promote you to use the PS credential. And to set one up is very simple. You simply click Add Setting, go here to Add Credential. You have a credential type. Now out of the box, there was only going to be PowerShell command or credential and certificate. So I can still upload a certificate if I'd like. But if I choose PowerShell credential, and then I would give it a name, maybe script account or something like that, not admin or guest or something like that. So you would define the credential. Now here is where I'd put the full username for the Azure Active Directory organizational account. Right now, it doesn't support the Microsoft Live accounts over the subscriptions. You have to use one of the organizational accounts. So you'd plug that account in here, you would fill in the password, and then that gets saved. Now that password is encrypted before it is placed into the centralized store, and it's only unencrypted when they need to send it off to authenticate to Azure. Okay, so with the assets out of the way, let's go back and take a look at the runbooks themselves. So when I click on runbooks here, I'll see my list of runbooks, and it actually can show me the last time it was run. I can do a few queries here to narrow some view down if I'd like. I'm just going to show real quickly this show simple example. When we look at an individual runbook, we again get a small little dashboard of when it was run, was it suspended, did it complete, etc. But I can also go in and look at the Configure tab, which gives me just the name of the runbook, a short little description if I'd like, some tagging, and then some options to turn on additional logging if I'd like. The schedule is exactly what you would think it is. It's associating your runbook with a particular schedule. Now if I go to Jobs, this is actually going to show me that history of when was this runbook last run, what were the individual job instances, and I can dig in and look at the outcome for each one of those jobs. The more interesting thing here is the Author tab, and that's actually where I can edit my runbook right here in the Azure portal. There's two different modes. There's a published mode, and then there's a draft mode. The published mode is if that runbook gets kicked off by a schedule, or if someone goes in and just says run, like down here at the bottom, start, the published one is the one that will actually get executed at that time. The draft is just what you would think it would be. This is where I'm editing the script and maybe testing it out. So I have the ability to enter a draft, make some changes to this, save it, and then test, or I can discard, go back to the way it was or whatever was recently published. Or if I'm happy with it, I can click the publish at that time, and it will be now the published version of the runbook. So this is an incredibly simple example using Azure Automation to connect to my Azure subscription and then get a list of the cloud services that happen to be running in my Azure subscription. So to first do that, I have to authenticate to Azure, and to do that, I need to get my credential. So if you remember, I had stored a PS credential in my assets called ubercooladmin_cred. And when I call get automation PS credential, that actually reaches out to that centralized store and pulls out that PS credential. I then store that in a variable, and then I call add Azure account, passing that credential. If you're familiar with Azure commandlets, the add Azure account is what you use to authenticate and pull back your list of subscriptions, and also get that authentication token that allows the PowerShell commandlets to store that token and pass it back on each subsequent call so that your calls to Azure are authenticated and secure. So once I've authenticated to Azure, I'm going to call select Azure subscription. Now this is just setting up what default subscription I want to use. And in this case, I have a subscription called MSDN subscription. I know it's very creative naming, but what's great about that is I'm actually using my MSDN subscription to test out Azure Automation, and remember, eventually it will be priced, and I do have some credits that allow me to test this out. Once it's out of preview, I can continue to test it out and try POCs and whatnot with it. So if you're not familiar with the fact that you can get credits with MSDN, go out, take a look at that, and get signed up for your MSDN benefits for Azure. It's a great way to try things out, and you get a certain amount of credits a month, and it just takes out of that rather than charge you while you're just trying things out. So now that I've selected Azure subscription, any of my subsequent calls are going to be authenticated, as well as it'll know which subscription I'm attempting to hit. And then I'm just going to do a simple get service, and then select that service name out so we can see what cloud services are actually running out there. So I'm going to go ahead and click test. It'll ask me if I really want to test. Yes, I do. And that's going to go off and submit my job. Remember, a job is just an execution instance of a runbook. So now it is going to start up, and we'll see this pane here where right up here it'll say queued, and then it will move on. While that's running, I'm going to flip back to the slides here real quick and walk through what's actually happening behind the scenes. So we have our runbook, our simple example, and Azure Automation has a set of automation workers that are just sitting out there ready to run automation scripts. This is a shared service, So there's a lot of these sitting out there. They're not running on VMs that are part of your subscription. They're running on VMs owned and maintained by Microsoft. So we have the runbook. When we execute a runbook, either by a schedule or on demand like I just did, a job instance is created and it's queued up. Now this is not to say that they're using a straight queuing mechanism or anything. I'm not talking about the implementation details here. I'm talking about the idea of how it works overhead, but it is queued. While it is queued, an automation worker is pulled out and is ready to be used. It is loaded up with your module, and for example, I have that certificate that I want to use for Twilio that will also get pulled over and made available for that instance to run. And then as the automation worker starts up, because it's using PowerShell workflow, it'll get its own run scope and it'll be isolated. And then of course we have that job data history in that centralized store where whatever is going on in that job is now being recorded. So the output and logging messages and that kind of stuff is now stored. So let's flip back over here and, whoops. We can see that it did complete. I have a status complete and I have these two outputs. So IAS-diag and ubercool QA. Whoops. And if we scroll right up here to my cloud services and take a look, I do indeed have these two that are running. And if I look at ubercool QA, I want to point out that it does have a production slot running. And I show that because my next demo, we're going to affect that. So we'll go back down here to Azure Automation. And I'm going to jump back to my slides. So we talked a little bit about the high availability aspect of Azure Automation. And this is that scenario where something may go wrong and we need to be able to react to that. So the way that Azure Automation does this is if for any reason the worker that I am using would fail, then it can spin that up. It can pull out another automation worker and it can spin that job up on the other worker as it is made available. Now you might be thinking, but what if I'm in the middle of my runbook? What if I'm in the middle of a script when this happens? Well, Azure Automation supports the suspend and the stop and the resume functionalities of PowerShell workflow. So as we build up our larger scripts and our larger runbooks, if we build in checkpoints along the way, then if it does need to get restarted because of something like this, then it would just restart at the last place that we performed a checkpoint. So let's take a look at checkpoints as well as a little bit more detailed example. So we're going to go back here to Azure Automation account. I'm going to go to my runbooks and we're going to take a look at this one called remove running deployments from subscription. Again, I'm not overly creative with my naming, but I think it tells you what it's going to do, right? So we're going to jump to author, and I'm going to go straight to draft so we can take a look at what this is doing. So as we can see here, the first thing I'm going to do is call a command called set Azure credentials and subscription. Now you're probably not familiar with that one, and in reality what I'm doing is calling another runbook. So if you remember from my very simple example runbook, I had 3 lines of code that was doing nothing but connecting to Azure. So I've encapsulated those 3 lines of code, or those 3 lines of PowerShell, in another runbook called set Azure credentials and subscription. I've given it parameters that can be passed in, which give me the subscription name as well as the credential name. And then those same 3 lines of PowerShell code that you saw from my original example are here. But what's nice about this is I can now constantly refer back to this runbook from anywhere in my other runbooks. So if we go back to my remove, we'll see that I call that right away so that I'm authenticated to Azure. Now the next thing I'm going to do is I'm going to determine which cloud services should be affected by this runbook. Now I do a lot of different talks pretty much like this, or I'm doing a lot of proof of concepts or demos, and I don't really want the resources running after I'm done. And I'm somewhat forgetful, and so I'll do a presentation and I'll forget to shut down the servers that were helping with that, or I'll be working on a proof of concept in a development environment, and I'll finish for the day or even for the weekend, and I'll forget to shut that down. So what this script is actually doing is going into my subscription, looping through all the cloud services, and of course we could make it loop through any of the assets in Azure, and shut them down or remove them. However, from time to time, you might actually be working on that proof of concept that you want to run overnight or want to run over the weekend. So I've created a variable, an automation variable, that I can pull out called shutdown ignore services. And I pointed that out earlier when I was showing the assets. And that was just a string. It can actually be a comma separated string. So I'm pulling this out into this variable service list to ignore. I'm going to write some output, which we'll see when it finally runs. I'm just trying to be nice for those who might be seeing the output of this job and just seeing the aftermath of it and not exactly looking at the code. So I do a small little inline script solely to get that comma separated list into an array of strings. So these are the particular services I want to ignore. And I write those out again so that somebody looking at the log can tell what happened. And then I'm using that same get Azure service command that I fired earlier in my simple example, except I'm filtering out any of the services that happen to be in that ignore services. And then I'm going to for each over each one of those. And you'll notice the first thing I do here is this checkpoint workflow. Going back to our discussion about high availability and going back to the fact that something may actually happen that brings us down, or maybe we just have a long-running workflow and we want to be able to checkpoint where we're at so that if the workflow gets restarted, it doesn't go redo a bunch of stuff it has already completed. So I'm going to call checkpoint workflow here, and what happens at that point is all of the information, all the variable values and those kinds of things are then persisted back to the centralized store for that job. And if the job has to be stopped or resumed, that information is pulled back out, and it would start from that location. So I've checkpointed. Now you'll notice the next thing that I do after the checkpoint is I call the same set Azure credential and subscription. Now you might be wondering, Mike, you just said that all the context, all the variables and all that stuff was saved. All the variables for that run book and their values were saved. However, the state of the worker process isn't really saved. So in this particular case, when we call out and we make authentication with Azure, we're getting a token back that is then held in memory there and used to send back for each call. If this runbook was to be terminated for whatever reason and then resumed, that token wouldn't be known, right? That token is not stored. And in fact, if it is over a long period of time between the time that it is suspended and when it is resumed, that token would no longer even be valid. And so in order to combat that, once we resume from a checkpoint, or we know that we could be resuming from a checkpoint at this point, I'm going to make sure that my script or my runbook is in a state that it is possible to keep going. So in this particular case, I know that I need to re-authenticate to Azure. And so I call set Azure credential subscription again, right after the checkpoint, so that I know it's in a good state and that I'm authenticated and I can continue on even if it's been hours or days since I originally got that token. The other place you might think about dealing with this is after you resume from a checkpoint, you have the capability in a runbook to reach out and grab assets from blob storage or other locations and pull them local so that you can work on them. And if you do that, that data won't be there if your runbook has been shut down and then resumed, because it may even be resumed on a different worker than it originally ran on. So again, any state for your runbook that you need to make sure is there, that is outside the variables, you'll just need to make sure you take care of that and make sure it's in place after each checkpoint. And then from there, I'm simply asking, is there a production deployment using the get Azure deployment, asking for a slot of production, passing in the service name as we're looping through each one. If there is one, I'm calling remove Azure deployment to get rid of it. And if there isn't one, I just write out some output, and then I do the exact same thing with the staging slot. All that is pretty straightforward. For the shutting it down, the real tricky part, or the part to remember, is any point that you put a checkpoint workflow, you need to make sure that you also revalidate any of your state that you're expecting to have whether it's a token or code or information that you've pulled down locally. So we're going to go ahead and run this. And again, once that gets kicked off here, I'm going to jump back over and we're going to talk a little bit about when we can actually have a suspension or a resume happen. So at first, the first one is obviously the high availability. We've already talked about that. If for whatever reason the machine that you're running on, it dies while it's running your runbook or your job, it will loop back around and bring it up on another worker. So that's one way in which your job may be suspended and resumed. Another is manual. While this is running, I can come over to the portal and I can actually hit suspend once it gets running. And then from the portal or from Azure PowerShell commandlets, I have the capability of going in and stopping and resuming active running jobs. So I can manually do it. I can also, within the script itself or within the runbook, I can place suspend workflow. That'll stop the workflow execution at that time and create a checkpoint, save that off, and it will just suspend the job. What's interesting about this mechanism is it provides a way for us to put in what's known as a human intervention point or a high point, where we can say the script has gone off and done these 18, these 20, 30 things or whatever, but before it continues, it needs a human to know, to say it's okay. And so it can call suspend on itself, perhaps most likely alerting someone that, hey, I've gotten to this point, it now needs your approval. And then the person can go off, make sure it's done what it needs to do, or it's set up correctly, and then it can say continue. So the human can then go in and either using PowerShell or the portal, or even your own code, since you can behind the scenes you can call in to tell it to start up. You can then kick that script back off and resume from wherever it left off. So again, doing it from the script just provides an easy way to interject human intervention. Now another one is exceptions. If you happen to catch an exception out of your script and that comes back up and you haven't handled it, then Azure Automation will suspend that job at that point. In your output, it will tell you what went wrong. It will tell you that there was an exception and what the exception was. And then through your own logging, you can dig in to figure out what exactly happened. But it will suspend the job if it gets an exception that you did not catch and deal with. And then finally, if you have a long-running job, remember this is a shared environment, and in that shared environment, they have a fair use policy going on here during the preview. And if there is a scenario where your job runs more than 30 minutes, it will be suspended. And then later, it can be resumed from where it left off. So if you have any job that runs a long period of time, you'll need to make sure that you're building those checkpoints and places where you can resume it. Now that might seem a little short. Hey, you're cutting me off while I'm running this job. But in reality, you should already be thinking about this, because the longer your job runs, the longer the window is that something might actually happen to the machine itself, in which case it would go down and be resumed somewhere else anyway. So be thinking about that. During long running, you may be shut off by the system and then resumed later, or long running just has a longer window in which something might happen that would cause the job to restart anyway. So let's go back and take a look. We see that I have completed. If we take a look here, it went through and it skipped, or it pulled my variable, just like I expected. It told me which ones it was going to be ignoring, and then it detected that deployment in my ubercool QA cloud service, and it called remove, which succeeded, and then it did not detect anything in staging. And if we scroll up here to cloud services and take a look, we'll need to refresh this. We can see now as I go into the ubercool QA that production system is no longer going, or that production slot, I should say. So we'll go back down here to Azure Automation. And if we take a look at the runbooks, and let's just go into this one, take a look at the jobs, and take a look at the history here. So here's a summary of one where I ran earlier, and I didn't have anything running, so it skipped over, and it basically skipped over the one I told it to ignore, and there wasn't anything else to shut down. But all that information is here. I can see that it had started, when it started, and when it completed. Now we've taken a look at Azure Automation out of the box. We've seen how you can create your runbooks, how you can create assets and share those across your runbooks in your account. So now let's take a look at a few scenarios that might be of interest or where you might use Azure Automation beyond just the simple examples that I've shown in my demos. So the first one is data maintenance or just patching. A great example was given by someone out on the Azure blog. If you go out there, there's a article about Azure Automation and using it as a replacement for T-SQL agent. Because if you're running Azure SQL Database, it does not have the concept of T-SQL agent that we're used to on premises. And so you can use Azure Automation as that replacement. You're creating a job that will connect to the database and perform whatever maintenance it needs to do, whether that's updating indexes or anything like that. And you can certainly schedule that with Azure Automation. And that makes a great replacement for that T-SQL agent. Now, another thing that they have shown off is there's actually a script out on the Script Center that you can use to download and import straight up into your automation account that allow you to do updates on your Azure virtual machines to patch them, right? So it does all the work with handling, patching the system, putting it back into the cycle, and doing updates on those Azure virtual machines. Because people have been looking at Azure Cloud Services, and one of the nice things about that is Microsoft handles all the patching and the carrying and the feeding for those servers. For the Azure VMs, that's really your responsibility. And so Azure Automation provides you a mechanism to do that upkeep across lots of your machines, or as many machines as you have, and do that patching and keep it consistent. So another workload that we can talk about is scaling to zero. Now this is very similar to the demo I just gave. Azure has some great features in the compute for auto-scaling, so scaling up and scaling back based on a lot of different metrics and looking at things, and that's available for websites, it's available for cloud services and VMs, etc. But it allows you to scale down only to 1. It doesn't allow you to scale to 0, meaning actually pulling everything off and killing the deployment. These are great for on-off workloads. Dev is obviously one of them, QA is one of them, test is one of them, but you can also have production workloads that are on-off. And what that really means is I want to start it in the evening and let it chug on some numbers overnight, and then when it's done, it should shut it off. I don't want to have those resources running during the day when they're not doing anything. So Azure Automation is a great way to schedule those, bring them up, let them chug on what they need to, and then have it check from time to time on whether it needs to pull them down, or maybe it's just on a set schedule and it pulls itself down. So another scenario for Azure Automation is monitoring and reacting to events. Now I would lean more towards the reacting to events part than the monitoring. And the reason I say that is this. So one of the things that you are metered on is how long your runbooks are running. And so if you have a monitoring, if you're using your runbooks to actually monitor something continuously, then if they're just sitting there polling over and over and over again, that's just going to eat through those minutes. What would be even nicer is if you could reach in and tell it to execute a runbook when an event occurs. And you have the capability with PowerShell to reach in and kick off an actual runbook instance or kick off a job. So I would look at finding ways to incorporate or integrate the execution of Azure Automation runbooks into your automated process. So if you detect that there is a problem, or if you detect an issue in your system, or maybe it's a good thing, it's not that you're detecting an issue, but periodically you want to go in and capture some information, then you just use PowerShell to reach in and tell it, hey, execute this particular runbook, which can go off and gather this information. Now they do have some samples. The folks at Microsoft have given talks at Build and at TechEd, and they give some examples where they're looking at other systems, like they're reaching out and looking at Google email, waiting for a particular email to come in, or they're using SharePoint, and when someone adds a item into a SharePoint list, that it reacts to that. Those are really good examples to show you just how powerful Azure automation is to be able to reach out and talk to all these other systems. So you have that full flexibility to deal with things within the cloud, as well as on-premises, if you can get access to it, as well as third-party systems. So speaking of running on-premises, you actually can use Azure Automation on-premises as part of the Azure Pack. So if you're unfamiliar with Azure Pack, this is the ability to install bits of Azure in your on-premises data center, so websites and Azure Automation. And you can actually set this up. You get your own portal, just like the Azure Automation portal. You'll see that in the Azure Pack portal, and you can create runbooks. You can interact with on-premises systems. And if you're familiar with Azure Pack and you're already running it, highly recommend you take a look at Azure Automation in Azure Pack. So let's finish and wrap up here. We've learned quite a bit today, hopefully, that humans don't scale very well. Consistency matters a great deal, especially in automation. You want to make sure you're consistently doing this, your deployments, or consistently doing your troubleshooting or your updates the exact same way, and automation helps you do that. We've also learned that having these automation scripts available makes us prepared for downtime, prepared for deployments. The more you can automate, the more your life will become easier and more predictable when things do happen, that you have ways to recover from them. So we looked at Azure Automation. What can it give you out of the box? We looked at demos and what you can use it for, and talked about some scenarios of how you may leverage it in the future. Now here's where I give you the warning. So I highly recommend that you be cautious with writing these scripts. Remember earlier I made a comment about using a high point or a human intervention point. You have access to all of your resources in Azure that you can do something with if you need to, or even reach out to other systems. All of those may or may not have an impact on your production system or your bill or anything like that. So you need to make sure that your scripts are well maintained. You need to make sure that your scripts, if they are dangerous to run, like the one that I ran as a demo, went out and basically killed anything in the subscription that wasn't told to be ignored. I really don't want to accidentally run that against my production subscription, right? So anything like that, make sure that you build in mechanisms to ensure that you don't take things down that you expect, or that you don't accidentally scale up hundreds of machines when you really only meant the thing to scale up once. Things like that. So just be cautious with your scripts and realize there's a lot of power with these things. So as I come to a close, I want to provide you with some resources. And I have placed a Cura out for you to go take a look at, and there's a bit.ly address for that. The QR code that you see will also take you over to this Cura. And on that Cura, there's a lot of different links that I found useful as I was learning about Azure Automation, but some of the more important ones are listed right here for you. So, of course, there's the Azure Automation page out on azure.com that you can go take a look at. There's the Azure Script Center link that will take you directly to the category for Azure Automation, so you can download some things. And then as you start working with Azure Automation, if you find that you wished it did something differently, or if you would like to see a new feature, please do go out to their user voice and provide a lot of feedback for them. And then if you have questions about how it works, or if you're getting started and you just want to know what other people have tried, go out to the MSDN forums for Azure Automation and ask your questions there. And I put a link in here to Resource Manager. Resource Manager is coming with Azure. It is something that they are working on, and it's part of it comes from the new preview portal and how they're doing rollouts for the templates. So the great demo where they rolled out an entire SharePoint farm with a click of a button. Those are all based on a template described in JSON that is then handed to Resource Manager, and it goes off and deploys everything. The demos I gave today were explicitly using the Azure PowerShell commandlets in the service management mode. So I was individually interacting with one particular cloud service or one storage account or something like that. Resource Manager will provide me the mechanism to be able to interact with or make changes to a larger set of resources, all as one group. PowerShell or Azure Automation does work with Resource Manager, so I just want to point that out. And finally, if you need to contact me, my contact information is down there on the screen. Feel free to reach out to me with questions about Azure automation, Azure in general, or if you have things that you would like to see appear on justazure.com, please reach out to me. Thank you very much, and I hope you enjoyed all the sessions that you've seen at Azure Conf. Take care, and happy automation.